Well, yeah, good morning, everyone. I'm not Benoit. My name is Ben Lyons. I'm a third-year PhD student at Imperial College London, looking at modeling and optimization of circular chemical production routes, mainly towards platform chemicals. Yeah, Chioma, quick introduction.
My name is Chioma, Udeozor, and I am the project lead for Sustainable Ethylene Production project on Tees Valley, which is somewhere up north. Part of the project is exploring the possibility of creating a sustainable ethylene hub on Teesside. So looking at everything from what feedstocks we've got on Teesside to what technologies and infrastructure exist at the moment that we could leverage on, and as well as the economics and the environmental impact of going that route.
Yeah, so I guess that's generally what the project was, looking at, Libby touched on ethylene, that chemical earlier, about how it's such an important platform chemical within the industry. So that was essentially our collaboration. I was providing some technical expertise in helping to model these routes and do the economic and life cycle assessments of them. But I think if we'll jump into the first question, Chioma, what would you say have been the impacts of our work together?
I think our work together has kind of given some insight into what could happen, what could be in terms of transition into sustainable chemicals production in the UK in general. So the Tees Valley, where I am based and where this project is based, is the largest chemical cluster in the UK and one of the largest in Europe. It houses up to 60 chemical companies, thereabout, if I'm not mistaken, please don't quote me. But NEPIC, which is the organization that I sit on, that I work with, is the Northeast Process Industry Cluster, is a non-profit organization that brings together all the manufacturing and the process industry within Teesside. So we have about 350 members that we cater to, and all those people are somewhere in the process industry supply chain. So going back to your question, the impact of the project would be showcasing what we have on Teesside and bringing it forward to the public and to the government to say, look, we can make Teesside the chemical hub, sustainable chemical hub for the UK, and we could bring jobs back to the Northeast, and generally bring manufacturing back into the UK.
Yeah, I think it was really nice working together with NEPIC. As you said, you have such a nice link to such a large chemical cluster. In academia, you sometimes feel a bit separated at times, almost, from actual industrial real-life impact. So, no, yeah, that was really nice to see.
Yeah, so we had lots of collaboration with a number of companies within the cluster and outside the cluster as well. We had chats throughout the project trying to understand what products they make, what kind of raw materials or feedstocks they use, and their decarbonization goals, per se, where they see themselves and what the challenges they are facing at the moment that sustainable production could help mitigate.
Yeah, try another question.
I think, what advice would you give to others embarking on a collaboration of this type?
Oh, it's probably the ones I didn't want. I'd say advice I'd want to give is just, it's kind of obvious, but you really do need to collaborate. Sometimes I feel like with these larger projects, it can be very easy to become siloed and look at the things that you yourself find interesting. I think it's very important to keep, communication between, say, the industrial and the academic partner to make sure you're both aligned on the direction the project's taking and what you actually want to get out of it, instead of you just ending up thinking, oh, that's really interesting, I'll steer the project in that direction for my own benefit. It's really, really important that it is mutual, the sort of results in the research direction it's taking.
Totally agree. I remember when we started with the ethylene, the bioethanol route for ethylene production. Ethylene is the chemical we're considering for the case study. It was easy at the time because we had the data we needed somehow. But when it got to the CO2 route, it became a bit more difficult. So I think collaborations like this, you have to put into consideration that you're working with organizations that you depend on for data, and they are not always forthcoming with data. You might have milestones to meet at certain time, and will be delayed due to the difficulty with accessing data. And when that happens, we already had plans previously before that time. It could sometimes cause sort of like a break in transmission. At the time when we needed that expertise of yours, you went on to something else, a different project, which made it difficult for the Tees Valley project. But thanks to Benoit, who is Ben's supervisor.
My supervisor, I should have said that.
Who's Ben's supervisor, we're able to find somebody else to help with the CO2 technical analysis. So when working on a project like this, it's always best to account for challenges that might come in the way that would prevent your project from running as you would expect or as you plan. So have a plan B and probably a plan C.
Oh, yeah, very, very good. So similar to what we had in the previous one, so what was the most surprising moment of discovery in the collaboration?
For me, the most surprising moment, not necessarily in the collaboration, but in the project entirely, because I don't come from a recycling or circular economy background. I'm a chemical engineer. I have a PhD in chemical engineering, but focused on immersive technologies, so VR, AR for chemical engineering education. So circular economy is not necessarily, it's something I got to learn from this project. And there's been a lot of emphasis on recycling as the way to go. What I learned from this project, from a chemical industry point of view, is that recycling is not the silver bullet. You require a lot of energy to recycle. You emit a lot of nasty things when recycling plastics. So I think, for me personally, I have learned, even in my household, we try now to reuse things as much as possible, because when I look at plastic, I just think about all the emissions that would come with going on to recycle them, if that's your plan. Oh, we could always recycle. Recycling is not the key. It's energy intensive, it's highly polluting, and things like that. So for me, that was the biggest learning.
Yeah, I think for me on surprising moments for the project was actually, so again, touching on one of the routes we looked at was bioethylene from ethanol dehydration. So there's actually a company on the Teesside cluster called Ensis, which manufacture ethanol in the UK from fermenting wheat. Non-food grade, so it's not competing with food sources. And we were looking at if we can undergo a dehydration reaction, which gives us this ethylene platform chemical. And the surprising thing was that when we actually ended up finishing the assessment and the modeling for this route, was actually how it was surprisingly competitive in like certain market scenarios. I think people in the research and chemical industry, all these circular routes or green routes, they're much, much more expensive than the standard. That's sort of a given. But this bioethanol route is actually surprisingly not as bad as we thought it was going to be. Again, over maybe a 5-year market period, on average, it was maybe 10 to 50% more expensive than the current market prices for ethylene, that's a really surprising result. So when you add on the LCA results, where you have a significant reduction in CO2 emissions, that route is now actually looking as a really promising option, especially for Teesside.
So of the 3 routes we looked at, CO2, plastic, and bioethanol, which is a biomass category, bioethanol seems to be the short-term solution or short-term feedstock for ethylene production. We had a workshop looking at trying to bring together stakeholders in the region and in the supply chain. And without giving them the quantitative analysis outcome, they picked that to be the short-term solution to sustainable chemical production on Teesside. So the report will be coming out soon. And for Teesside, we think going the bioethanol route for ethylene production would be the best way to go so far. It's the low-hanging fruit of that. Thank you.
Yeah, thanks very much.
Ding.